So we have in our last class covered till syntax and comments and variable type and data types, right? So we will get started with data type casting, and then we are going to cover operators, operator precedence, and we will also try to cover some of the common libraries, the main method, how to take user inputs. These are all small modules. These are not going to be pretty big. And then we will also see how to take user inputs, right? So let's get started. I'm just using the workbook which we used last time. I'm just,
Many, can you please zoom in
yeah, sure. Is this good now?
a little bit more, please? Yeah, better.
Sure. So I'm just going to continue to use the same workbook which I used last time, and I will publish it there on the dashboard as well. So this is the place till where we covered, right? We were looking at the Boolean data types, true and false, and we have already covered that, right? So let's start with what is the casting in Python and how it is done and why is it important for us to know. So what happens is at times you may need to override the default data type, right, for any value. And one use case would be if you really want to store numbers as text and do not really want to do any mathematical operation on them, and you have a specific use case, then you can actually store numbers as text. The other thing could be that you may have numbers stored uh, as string inside any variable, and you may want to convert the number which is stored as string into a number, right? And this is where casting comes into picture. So casting is where you want to change the data type of any Python variable from whatever variable type it is into right now into the variable type of your liking. I will give you an example to make it a little more clear. But what we are trying to do with casting is we are trying to change the data type of any variable from one type to another. Simply put, this is what we do in casting. So this is these are a few examples, right, that I've taken here. When you look at it, yeah, when you look at it, x is equal to int1. Now earlier what we were doing is we were just writing x is equal to 1, right? This is how we were writing the syntax. But here the difference is that I have specified int1, right? What does it mean? That I specifically want to tell the interpreter that store this number, whatever is inside the brackets, as an integer, right? As a number. There should be no decimals and it will not be a string. So once we do that, then we are typecasting this number into string, right? So this is the number which is the number of our interest, right? And by enclosing this into int brackets, opening brackets and closing brackets, we are typecasting it as one. So although it does not make sense to do this here because this number one is already an int number, right? But what if, let's say you have a floating point number, right? You have a value which is 2.8. This is a floating point number, right? Which means that you have decimal values as well, right? You have an integer part of this number and then you have a decimal part of this number. So the integer part of this number is 2 and then the decimal part of this number is 8, right? So this is 2.8, right? Can we store this as a int? Yes, we can. But uh, what will happen is that the floating point number will get truncated, right? So it will get stored as 2 and we will just see how this works. So let me do one thing. Let me just remove this line from here and print the value of. So let me first execute this and then print the value of x. So x is y. Sorry, x is 1. This is very simple. There is no problem with this. What happens when we print the value of y? So it is giving me 2, right? You see what is happening here? This number 2.8 is getting converted into int, integer number. And that is why it is being printed as 2 and not 2.8. If we just remove this part and then execute y, then this is going to show 2.8. right? So this is an example of where typecasting would work. Can you now, so moving forward, right? The example with z, z is equal to int, and then we have written 3 inside double quotes. So first, let's do one thing. We should first try and print the value of uh, or the type of z, right? And see what it is. If we write 3 type of 3, then it says int, right? But if we type 3 inside double quotes, then if you look at it here, it says type is equal to string, which means if you enclose any numbers inside double quotes, then it becomes a string, right? So what is happening here? This 3 is actually a string stored as character 3, not number 3. And we are actually trying to convert 3 from a string literal to an integer variable. And that is what we are trying to do. So if we print the type of z, then this is going to give me int, because here before assigning this string to z, we are converting this into a string. So although the type of double quotes 3 double quotes is going to be str, but type of z is int, because we have converted this specifically into an int variable. And then if we now print the value of z, then this is going to give me 3, right?
Yeah.
So this is where typecasting comes into picture. You must be wondering, what if we typecast 1 into maybe a float, right? Is that supported? So let's see what happens, right? So x is equal to float, and let's say 5, right? And then print the value of x. So see what is happening here. Now this is an integer number, and we are typecasting this into a float data type, right? So what is happening? It is storing this as a float number, but then since we do not have any decimal part here, it is showing this as 5.0, which is fine, right? This is not at all a problem, right? All right.
Yeah.
Yeah, so this is a very small topic, guys. You can use either int, you can use either float, or you can either use str, right? Let me quickly show you str example as well. We have already seen int. We have seen example of float as well. So what if you were to convert or typecast into str, string, right? So s is equal to str. Let's say I write this number 50, right? Then what is happening? This int number is getting converted into string, right? Let's see how can we be sure that this is actually getting converted into a string. So if you see the type of, this is the only tool that we have. We can check the type of s, and when we check the type of s, it says str. So this is confirmed. This is definitely str. Now let's do a few more confirmations, right? On a number, we can do any arithmetic operation, but can we do any arithmetic operation on a string? We cannot, right? We cannot. So what we can do is, uh, let's first print the value of s, and it is giving me 50. What if I print the value of s minus 15, right? Now here we have a problem, right? Let's see what the problem is. Unsupported operand type for minus.
Manish, your voice is breaking.
My voice is breaking.
Yeah.
Okay. Um, is this any better now?
Not yet. And also, I'm getting the screen that print as and then print as minus. Nothing over there.
Sorry.
Uh, in the script, in the 14th number,
Haha.
yeah, now it is updated. I think the screen has been hanged also.
Okay. Rahul, is that a problem for you as well?
No, no, no money.
So Gajendra, is there a possibility that you may be on a small, sorry, slow internet connection or something at
Yeah,
your end?
might be. Let me reconnect it.
Yeah, but then do let me know if you find any issues. We can probably pause for a while to fix you this.
Just give me 2 minutes.
Sure, sure.
Yeah, yes, we can continue.
Sure. All right. Thank you. So what I was trying to show you guys is here in this case, right? We were trying to do a mathematical operation on a data on a data type which is actually stored as string, right? And this is resulting me in an error. And I purposely wrote this code so that you know that for sure this is a string data type, and this is not a number, although it is storing 50, but then it is storing 50 as a string, right? It clearly says unsupported operator or operand type minus. One of them is string, another one is int, right? This one is string, this one is int. This is not supported. So I'll leave this code here so that you guys actually run this and see the error yourself to be doubly sure that this is actually string, right? There are these, so in terms of you wondering why we would want to store integer as string or string as integer. I mean, there is no real use case of this that you may want to do it that ways. But what happens is, let's say you are given a data file that you need to work on, then you really do not know how that data file is structured and what data type that data file consists of or contains, right? In case there is a field where there are numbers, but then those numbers are stored as characters or variable characters, and you need to perform any operation, mathematical operation on that field, then you need to convert them into integer or float depending on whatever your need is. And this is the only real life use case of typecasting. So this was a small topic, guys, and I'm kind of moving on to the next topic, which is what are the arithmetic operators inside Python. So this is going to be very simple. There is nothing much to cover here. We already know these notations. I will just add a couple of them which you may not be aware. So, arithmetical operators are operators which are used to do mathematical operations on integer and float data types, right? Plain simple. So if you have a float data type or integer data type, and let's say you want to add them or subtract them, then these are the operators that you use, right? Very simple. These are, let's say A contains value 5, B contains value 10. Then you can write some kind of a expression like this, which says C is equal to A plus B. So what is going to happen is the value of A plus the value of B, this is going to get assigned to C, right? So the value of A is 5, value of B is 10. So you can very well say that C is going to contain 5 plus 10 is equal to 15, right? And print C is definitely going to give you 15 in this case. So I've already run this code, and this is uh, showing an output of 15, which is correct, right? So let me extend this further. What we can do is we can also write the other set of codes, right? We can change it to b minus a, and then also try to print the value of d. So b minus a is going to be 5, and same ways you can do multiplication, you do division, right? So let me quickly do a couple of these. A into b, a divided by b, right? And I can print these really quickly. Yeah. So see, what is happening in case of a into b? A into b, 5 into 10 is 50, and 5 divided by 10 is going to be zero point 0.5. This is coming from f, right? F is equal to a by b. Now you see, we are not doing any kind of a typecasting, but automatically Python is figuring out that should be stored as floating number because it has decimal part in it, so it automatically converts this into a floating uh, variable or a float variable. So these are the common four ones, right? I will quickly show you a few more, which is modulus and exponential, right? And this is interesting, right? So I will probably use another cell for this, or probably do here itself. So mod is equal to what? Mod is equal to, we write a%b, right? And let me actually take another example for this. Right. So A is equal to 23, B is equal to 4. Mod is equal to A. Now the operator that we are using is percent, right? So what it gives you is, let's first print and let's see what it is giving us, right? So what it gives you is the remainder, right, of the division operation, right? So what is happening here? It is the same as division operation, but instead of giving you the operand, it will give you the remainder of this operation, right? Division operation. So if you divide 23 by 4, then you are going to get 5 as the divisor and 3 as the remainder, right? And this is what it is giving you. So if you need to find out the remainder of the division operation, you can use this operator percentage. So this is to find the remainder, modulus. Now look at the exponentiation, right? So again, I will take this example. A is equal to 2, B is equal to 4. Um, okay, and here the operand is going to be a little different. So what this is going to give me is,
Hmm.
it is going to give me A raised to the power B, right? Gives A raised to the power B value, right? So this is what it is going to give me, right? Instead of a single multiplication symbol, I'm using two multiplication symbols, and this is the only difference. So what this is going to give me, it is going to give me 2 to the power 4, which means 2 into 2 into 2 into 2, right? And when we do that, what we are going to get is 16. So again, this is very simple, guys. I mean, nothing to actually mug up or remember. You just need to know that there are these operators. Whenever required, you just need to use them as and when required, right? So let's try and change these values, right? 3 to the power, let's say 3, right? Let's see what it gives me. Ideally, I should be expecting 3 to the power 3 is equal to 3 into 3 into 3, 27, and this is what it gives me, right? So pretty simple, guys. This is also not very difficult topic. What we have done is arithmetic operators. So whenever we need to do any arithmetic operation, we can actually use these operators, right? Plus, minus, multiplication, division, modulus for remainder, and double star or double multiplication symbol for power. That's what we can do. So moving on, what we need to do is look at the Python assignment operators, right? So what is an assignment operator? So we have already used one assignment operator here, right? A is equal to is a assignment operator. What is happening? When you write A is equal to 3, the value on the right is getting assigned to the variable on the left side, right? So 3 is getting stored into this variable named A. Okay. What is happening here? Again, we are using a equal to operator, and whatever is on the right side, the outcome of this is getting assigned to the variable on the left side. This is what is happening here. So 3 to the power 3, 27 is getting assigned to exp, and that is why when we print the value of exp, we are getting 27, right? So what is what is it that this is equal to operator is doing, right? This is equal to operator is actually responsible for assigning the outcome of whatever expression you write on the right side to the variable on the left side. This is what this operator does, and this is what the primary assignment operator is. So it is equal to, right? And there are a few others as well which we will look at, but then if we simply write a is equal to 10, then what we are doing is assigning value 10 to a, and this is a plain simple example of the basic uh, assignment operation, right? So is equal to is a assignment operator, the very basic operator. Okay, so that is done. Let's print this value. We have done this multiple times by now, and we know what is going to happen here, right? Let's look at some other operators. So the some of the other operators are plus is equal to, minus is equal to, right? And let's see what it does, right? So a plus is equal to, let's say, 5. So what does it give me? Let's see. So a plus is equal to 5 gives me 15. What does it mean? It is the same as if I'm writing a is equal to a plus 5. It is a different way of, it is a simple way of, or let's say it is a different way of writing the same expression. So a plus is equal to 5 is a short form of writing this simple statement a is equal to a plus 5. There's no difference whether you write a is equal to a plus 5 or you write a plus is equal to 5. It's going to be the same. It is going to be interpreted as a is equal to a plus 5. So nothing new here. We have already seen what will happen when we write a is equal to a plus 5. The outcome on the right side is going to be assigned to the variable on the left side. And this is what is happening here as well. Same ways we can write other expressions for assignment. A minus is equal to 7. So this is going to be interpreted as, if we are writing a minus is equal to 7, is going to be interpreted as a is equal to a minus 7. And when we do that, this is going to be interpreted as 10 minus 7. So I'm expecting a value of,
No, it would be the 15 minus
yeah,
7,
it will
right?
be 15. Yeah, it will be 15 minus 7. Because what is happening is, the value of a has changed here, right? The value of a has changed to 15, and now it is going to get interpreted as 15 minus 7, which is going to be 8. So this is correct. This should not be 3, it will be 8. Okay, all right. What else? We have similar ways. We have the other operators. Into is equal to, divide equal to. I will probably leave this to you guys to extend this further, because this is going to be no different than what we have already seen. We have already seen all of these operators. The only difference here is that it is going to be a short notation. So instead of plus is equal to, minus is equal to, the other operators that you can use are into is equal to, divide by equal to, percent equal to, and into equal to, right? So all of these are operators that you can use for assignment as well. And if you really do not want to use or write it this way, that is totally fine. You don't have to use it. Like, this is not a mandatory, uh, uh, you know, step that you need to actually write a plus is equal to 5. If you're comfortable writing a is equal to a plus 5, that is totally fine. You don't necessarily need to actually use these short notations. It's only when you think that this is going to be more readable or easy to write, you can actually save a few clicks for yourself. So I'm just leaving this for you to take this forward and actually do the rest. I can probably do the modulus so that you can, um, uh, 25. Let's say, let's do 25. And a modulus is equal to 5. When we do that, then what is happening is a modulus 5, right? So can you tell me what is going to get printed because of,
0.
out of this? This is going to get us 0, right? Because 25 is divisible by 5, and the remainder in this case is going to be 0, right? So This is going to give me 0, right? Perfect. So with this, we are done with this as well, right? Python assignment operators. These were, short notations for what we can do with is equal to as well. These are short notations. So nothing new in here. So extend this for the other two, which I am skipping for now, and let me know if you guys have any questions. So now comparison operators, right? Comparison operators are used to actually make comparisons, right? So we have seen two type of operators right now, or so far. We have seen arithmetic operations when we need to do any arithmetical operation using variables. And then we have seen assignment operators, right? How do we assign the outcome of any expression to a variable? These are what we have already seen. The third one is where we need to see the comparison operators, right? So what are comparison operators? So comparison operators are actually required to make comparison between two variables. So let's say we have a variable and you have a value 5, another variable value 7, and we just want to print a is greater than b. So when you do this, then it says false, which is correct actually. A greater than b is false. A is not greater than b. A is equal to 5, b is equal to 7. So in this case, what is happening is using this greater than operator, I'm able to make comparison between these two variables. I'm able to make comparison between A and B using this greater than variable. There are, and that is why this greater than, symbol is actually a comparison operator, one of the comparison operators. The other comparison operators are less than. So is A less than B? If you do that, then it definitely is true, right? Either of them has to be true, right? The other thing that we can do is equal to equal to. So just mind the fact that this is not a single equal to, because single equal to is a assignment operator. When you write A is equal to B, then what you're trying to do is you're trying to assign the value of B into A. If you really need to compare if A and B are equal, then you need to specify 2 is equal to's. And when you do that, of course, these are not equal. So you will get a value of false. Now, what are the other operators, right? So we have equal to, we have not equal to, right? We have greater than and we have less than. So let's see not equal to. Not equal to is simple. You can just specify, exclamation sign and equal to, and this is basically going to be interpreted as whether A is not equal to B or not. So A not equal to B would result into true, right? Because A is not equal to B. So see, this is resulting into a true. Same ways, and primarily these are the four ones, right? Greater than, less than, equal to, and not equal to. But then you can also extend this use case into, let's say, uh, greater than equal to. If you want to do that, then that is also possible. You can also do less than equal to. That is also possible. And if you see greater than is equal to 2 would mean either greater or equal to B, right? A should be either greater or equal to B. This is what it means. And this one would mean A is either less than A or equal to B. So if either of these conditions are true, then you will get a true, right? So essentially what is happening in this case is when you write A is greater than equal to B, then it is as good as writing this as well as this, both the statements together. You're doing both the comparison at once when you write this, right? So these are the comparison operators, and yeah, this is what it is. These are all the comparison operators: greater than, equal to, not equal to, greater than equal to, and less than equal to. And you can change the variables and play around with these to figure out how it works. Again, very simple concept, guys. There is nothing much to explain here. You may have already used them in your algebra, basic algebra, and it's the same notation which gets used here as well. The only difference here may be in algebra we do not use double equal to. We may not be using um, not equal to like this. There has to be a different operator there. But then these are very simple in Python. Then we have something called as Python logical operators, right? Now, what is a logical operator? So logical operator is where we need to, specify, multiple conditions. We need to use uh, our logical operators. So let's say if there are more than one conditions that need to be true, right, or false, then how do we deal with that kind of a situation, right? So let me first show you what actually I mean here, and then we can actually take it from there. So, so let's say you want to, yeah. So let's say you want to do any logical comparison, right? And then you are building some kind of a logic where, uh, you have two outcomes, right? Uh, and this is this is input number one. This is my variable one. This is my variable number one. This is my variable number two, and this is my outcome, right? So in this case, what should happen? Let's say the values are such that if your first variable value is 0 and second is 0, you want the output to be 0, right? If you have the first value as 0 and the second value as 1, you want the output to be 1. If you have your first value as 1, second value as 0, you want the output to be 1. And let's say in the fourth case, if both of these values are 1, then also the output is going to be 1. In this case, what you're trying to do is you are trying to implement a OR logical operation, which means what? Which means that when either of these values is 1, then the output should be 1, otherwise 0. So since neither of these values are 1, the output is 0. But in this case, this one is 1, right? So you have an output of 1. Here, one of the values, which is the first variable, is 1. So we have an output of 1. And here, both of them are 1. So we can take just either value, either this or this. And that is why the output is 1. So this is one scenario, right? The other scenario could be, and I'm just going to draw these boxes now, not write the header. The other implementation could be where we have a similar structure, but then the outcome is going to be different in this case, right? So how the outcome is going to be different? This is my output. This is my output. This is my variable 2. This is my variable 1, right? So here the output is going to be a little different, right? When both of my values are 1, then I should get a 1, and otherwise I should get a 0, which means this will be 0, this will be 0, and this will be 0 as well. So what is happening? We are trying to do a AND condition here, right? We're trying to do a AND condition, which means when both the variables are 1, then only give me 1, otherwise give me 0, right? This is what is happening. When both the variables are 1, I'm getting a 1, otherwise I'm getting a 0, right? Here both the variables are not 1. One of them is 1, one of them is 0, so we're getting a 0. Here also one of them is 0, another one is 1, so we're getting a 0. And here none of these values are 1, right? So we're getting a 0. So whenever we need to implement such kind of logics, we can actually use these logical operators or and. It totally depends on what our need is, and this is what we are going to see. How do we implement this in Python? It may look a little complicated, but then the implementation of this is going to be very simple, right? I'll tell you how to use this. So what we will do now is we are going to take we are going to take a few variables to explain this as to how we can actually use this. So again, let's take simple variables. 5, b is equal to, let's say, 7, c is equal to 10, right? Now we want to check two conditions simultaneously. A is greater than b, and then write or b is greater than c. And let's reverse this. So what are we doing? We have already seen what this statement will do, right? When we write a greater than b, then this is going to be resulting into false or a zero, because a is less than b. But what if we write another statement, a similar comparison statement, c greater than b, which results into true, right? C is greater than b, and we separate these two statements with a or statement, right? Then in this case, what we see is one of them is resulting into a 0, false. Another one is resulting into a 1, true, right? And what happens in case of a 0, 1? In case of a or, it will give me 0, 1 in case of a or, right? When we do that, what did we see? This is going to give you 1, right? Or true. So this is what will happen, right? When we print the value of it, this is going to give me true, right? So or needs to be written in small letters, yeah, as per the syntax, not in caps. So what is happening? This is going to be false and this is going to be true, but an or operation when done between false and true, it is going to be true. Either of them being true will result into true for this statement. If we do the same for and, then what do you think it's going to happen, right? This is going to be false or 0, and this one is going to be true or 1. So in this case, when you do a and operation, since both of them are not 1, this is going to give me false. So and or operator, either of them are used when you are required to check or validate more than one conditions at a time, and that is where it needs to be applied. Otherwise you do not necessarily need to use them. You can also use multiple ands, right? You can also use multiple ands, something like a less than c. You can do that. That is totally fine. You can do this as well. Now the result is definitely not going to change because a is less than c is true, but all of these conditions needs to be true, right? Because we are using and this statement is also true, but then this statement is false, right? When we change this operator, a less than b, then what you see is all of these three conditions become true, and in this case we are getting a true here as well. Clear? Do let me know if you have any questions. This may be a little tricky if you are doing it for the first time.
No question.
No,
Okay.
I'm good.
Okay, perfect, guys. I'm glad that you guys are following along really well. So what I will do is, just for the sake of printing at least one value which is uh, false, I'm just changing this statement here so that you can, while practicing, take a note of this as well and do this yourself. One more operator here is, so we have already done or and the one more operator is not, right? So let's see what not does. So not is just going to check the opposite condition, right? So again, I'll take a very simple example because we do not want to complicate these examples. When you write not a is equal to b, what do you think this is going to result into? Let's first only concentrate on a is equal to b, right? A is equal to b is going to be false because a is not equal to b. But when you negate it by writing not, then you're actually flipping the outcome of this, which means it will
Yep.
print a true,
True.
right? Because it is checking whether A is not equal to B or not, right? It will be the same as writing this statement, not equal to B. This is also going to be true. Sorry. This is also going to be true, right? Because A is not equal to B. So these are all different notations, guys. You may not need to use them all because, you have already seen so far that there are some of these are repetitive in nature. There are more ways of doing the same stuff. There are more than one ways of doing the same stuff. And you always have a choice. I mean, no one is going to force you to write or use a not operator. If you want to write it this way, instead of writing not A is equal to B, if you want to write A not is equal to B, it is totally fine. No one is going to actually challenge you in this, that why are you following this approach. They both do the same stuff, and you can have a preference of using one or the other. That is totally fine. So with this, we come to the last operator, right? That we need to see, set of operators, membership operator, right? So membership operator um, is an operator which checks for a specific value inside a list, if that is present or not, right? So let's say, and this is where Python code becomes very meaningful or self-explanatory at times, right? So I'll take a few examples of fruits here, and and then we will make it a little more clear, right? So we have these fruit examples, right? We cannot leave mango in the full mango season. So these are my fruits, right? What I'm going to do now is print, and then take another example. My fruit is equal to, let's say, banana, and your fruit is equal to guava, right? What will happen if we, so now what do you want to do, right? We want to check whether any of these values are available in this list or not, and this is where the membership operators come into picture. So what we can do is we can check, and this is going to be very self-explanatory. Print my fruit in fruits. That's it, and see what it has done. My fruit, it has a value of banana, and fruits is a list which contains these five, the names of these five fruits, right? So this in operator is going to check whether the my fruit value is present in this list or not. As simple as that. If it is available or if it is present, then it is just going to give me a true. Otherwise, it is going to give me a false. So let's try to do this with the other variable, right? Your fruit, and your fruit has a value of guava, and we know for sure that this is not available here. So the second value is printing a false. As simple as that. So what we are trying to do, we are trying to figure out if this variable, the value of this variable is a member of this list or not. If the value of this variable is a member of this list or not. Simultaneously, we also have a not, we always have a not, right? We have is equal to, then we have not is equal to, then we have uh, or and, but then we also have a not if you want to check the negative condition, right? Same ways, we for membership we also have a not in, right? So when we do a not in using your fruit, then it is going to give me the negative condition, which is true in this case. And this is going to be very simple, guys. I mean, if you look at it, what is the benefit of it? You do not need to, if in any other programming language, right? Imagine what you would have to do to check whether the value of this variable is present in this list. You will need to actually compare this value with this value first, then this value, then this value, then this value, and then this value, right? And keep printing whether this value is present or matching in this list or not, right? So you'll need to actually write a recursive or a uh, iterative statement. You will need to probably write a for loop for this. But what is happening here? We just using this membership operator in or not in, we can simply write it as if it is a plain simple English statement, and it gives you that value. You do not necessarily need to write a for statement or a for loop for this. And this is where you are getting a early glimpse, or a very early signs of why writing code in Python is so simple, and why it does not necessarily need you to have a programming background to actually write code in Python. This is going to be very simple, and this is your first glimpse, right? If you have not used membership operator, you'll be probably amazed by now as to how simple it was for you to search a value within a list. What is it that we are trying to do? Simply put, we are trying to search a value inside a list. We have already seen what a list is. We are going to see it in very much detail later on. But then for this example, taking example of a list was the most appropriate. Right? So do let me know if you guys have any questions. Otherwise, I'll move on to the next topic.
Yeah, we
No,
can.
Perfect, perfect, guys. So I'm glad that you guys are following along. And with this, we are done with the operators, right? So what we have covered is their typecasting operators, and we need to quickly look at operator precedence. Now, this is also very important, right? So let's pay a little attention. Um, I'm 100% sure that you guys may already be knowing, but still, let's cover this and not leave this to any doubt. Operator precedence, right? Okay, so just let me know what will be the outcome of this statement. A is equal to 5 plus 7 into 10. What do you think if I print the value of A? What is going to get printed?
75.
75? Yeah,
70.
but
75.
75. But why not 5 plus 7, which is 12 into 10, 120? Why not 120?
Because first we have to perform the multiplication operator, and after that we will perform the add operator.
Right. And I think we already have learned all of this in algebra. This is the same concept which is applied here as well, right? This is not going to get executed from left to right. This is always going to be having a precedence, right? And then the precedence that it works with is the same, right? That we have, learned in our
Okay.
childhood days, right?
Model
BODMAS, right? This is bracket. This is, yeah, let me know. This is of or multiplication.
uh,
This
right.
is
Division.
division. This is
Multiplication.
multiplication. This is addition,
Addition.
and this is subtraction,
That's it.
right? So this is how it is, right? I'm just going to cut this, put it here for your reference so that you can use it. But let's get back to one question. What if your answer was correct, right? What if I want the 5 plus 7 to uh, get calculated first, and then 10 multiplied with this later, right? What if I want 5 plus 7 to be calculated first? What can I do?
And then
Bracket.
we put in bracket.
Perfect. So I can actually put this inside brackets, and when you do that, then since we know that the precedence or the precedence or then the importance of bracket is more, then this is going to get executed first, and then this, right? And then in this case, if you look at it, the outcome is
120.
going to be 120, right? So if you know, guys, if you know this already, this is totally fine. I just wanted to know because at times what happens is when people do not realize that there is, if they use multiple operators in the same statement, then there is operator precedence which comes into picture, and it may be very misleading and confusing because it may not match with the results that you get, right? Since you knew this, that it was very clear to you guys. So we are just overwriting the operator precedence here by using brackets. So with this, guys, this module is finished. What I will do is I will override the same, and this is an extension of the same Python file notebook which we used last time. So I'm just going to overwrite it here. Um, Python, no, this one. There are types and operators, right? I'm just going to overwrite it there so that you get the updated one. So you will need to download it again to get the workbook which I used today, Python notebook which I used today, right? So
Okay.
let's move on to the next set of topics, right? Which is what are the common libraries? What is the main method? We have already done this, so we will see how to you take user inputs. And with this, we'll be able to finish the next module as well. This is going to be very simple. So some of the common libraries, right? Some of the common libraries, right? So some of the common libraries which are part of Python core are Pandas, NumPy, and Matplotlib, right? These are going to be very crucial for you to understand in a little detail, I will say. But right now, what we are going to do is we are going to look at them into uh, a little briefly, right? So these are common libraries. These are just introductions to Pandas, NumPy, and Matplotlib. When you look at the module, we are going to actually do these in much detail later. So there's a whole module for data frames pandas, and then there is another whole module for NumPy, and we are also going to cover Matplotlib as well. So this is going to get covered in much more detail. What we are going to do today in this module is a brief introduction so that you have some awareness of these common libraries as well. And these are part of pandas, these are part of uh, Python core, right? These are part of Python core. So what is pandas, right? Simply put, if you really need to work with a data frame or some kind of a tabular structure, we use pandas, right? Let's see how pandas is defined, right? Pandas is a high-level data manipulation tool developed by Wes McKinney, and it is built on a NumPy package. So this is another package that we are going to look at briefly today, and its key data structure is called data frame, right? So this is what is important for us. It provides you pandas library provides you a data structure, and it is called data frame. We will see now what a data frame is, but then definition wise, data frame allows you to store and manipulate tabular data in rows of observation and columns of variables, and there are several ways to create a data frame. So simply put, if you have any doubt as to what a data frame is, I will clarify this doubt for you right now. A data frame is nothing but, if you have seen a tabular structure where you know specify a few columns and then rows, a data frame is the same as that structure that you may have already seen, right? So this is our table or a tabular structure looks like when you store any data inside a database, right? Or inside a database table. It will have rows and columns, right? The first row will have all the column information, right? So let's say it is ID field, then we have name, another field for name, then we have age, and then let's say we have gender or sex. So these are the IDs, right? Now what will happen, right? For the first person, you will have the corresponding values for all of these fields. So 25, I'm just taking hypothetical numbers, right? Male. The second row will have, you know, the second ID, another person's name, hypothetically B, 30, and gender or sex as female, right? This is a table. How you define this inside a inside a database, right? This is a simple table, right? Arranged into columns and rows. These are my columns, column names, and these are my row variables, right? These are my column names rather. So a data frame inside uh, Python is going to represent the same structure. So it is going to be no different. This is what a data frame would look like inside Python as well. This is not going to be any different than this table, and we will just see and figure out why I'm saying this. So again, just reiterating, Pandas provides us with a data structure called data frame. And if you want to understand it in a layman terms, this is going to be no different than a table, right? The table structure that you have already seen inside, how it exists inside a database. And we can actually define and use them. So Pandas is a library, right? And first thing that you need to do before you can use any library is you need to import the library. And this is a statement that we use to import the library. It starts with import, then the name of the library, which is Pandas, and then we just give it a alias so that every time we don't have to write this full name, you can just write this small alias to refer to this library. So it's something similar as an alias name or a nickname, you can say. So we are importing pandas, and then going forward we are going to call pandas as PD. This is very simple. So let me execute this. Executed, no issues. Now how can we actually define a data frame, right? If you look at it, what is happening here is we are calling a function named data frame, right? And inside this, if you look at it, we have briefly seen what a dictionary is, right? In our first class, or second class rather, we have already seen what a dictionary is, right? So let me just open that part up. See, dictionary, right? Name John, age 36. This is the example of a dictionary that we picked, that we have already seen. The data type is DICT. So what we are trying to do is we are trying to store this dictionary inside a data frame, and this is what we are trying to do. We are we are This is a dictionary, right? Dictionary is defined inside curly brackets, opening and closing curly brackets. And what we are trying to do is we are providing a column name which is role, and then specifying these values 1 to 6, and then we are specifying score, another column, and then these also have some random values between 1 to 6. When we pass this dictionary inside this function named data frame, then what happens is this dictionary gets converted inside into a data frame. And this is what is we are going to see right now. Let me execute this statement. So done, no issues. Now when I print df, which is nothing but my data frame, then see what is happening here. These are my row numbers. You can just safely ignore them. But what happened to this dictionary? This dictionary got converted into a table or a data frame inside Python. So these two names, the key value pairs for the keys of this key value pair became the columns, role and score, and then the corresponding values, they are very beautifully laid down as row values for role, and then the corresponding values for score are actually getting laid down as the score values, in the corresponding rows. So you can see for the first row you have a value of 1 and 4, and then in the second row you have a value of 2 and 2, in the third one you have a value of 3 and 3, and then this is how it is following till 6 and 1. So this was a simple example. If you really want to change this or extend this, we can make this a little more meaningful as well. And what we can do is we can take example of this one, right? ID, name, age, and gender, right? So let's quickly change this, and this is going to be very simple. Whatever fields you need to define, you need to define them as keys, and then the values you can specify inside um, the value pairs, right? So for simplicity, I'm just taking 5 rows. The second field that I need to define is name, age, and gender, right? So let me change this to name, age, and gender, and we will change these values, right? So for simplicity, I'm just taking these names. Okay, let me take real names. Um, right, and then the corresponding ages, right? So we can take any values, right? Any random values, assuming these to be, we just need uh, 5 values, right? And then the gender, right? So let's make them meaningful. And you can take them as, put them as single brackets. You can put them as double brackets. Sorry, single quotes or double quotes. That is totally fine. So male, 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 female, and male. Yeah. So these are my data frames. Now, what is the problem? The problem is that we missed putting in a comma here, and after every key value pair, so when the ID values ends, we have to specify a comma. When the name values end, we have to specify a comma. We were missing because we added a new column, we missed putting a comma there. So this statement is executed, guys. There is no problem with that. Let's see what happens when we print the data frame. Now, very beautifully, all of this is getting converted into a table, which is my data frame in this case. Let me print the type of it, right? This is very interesting always when you are working with a new type of a data type. See what is happening right now. When we print the type of df, it says pandas.core.frame.dataframe. So this is definitely a data frame. Df is definitely a data frame. We know for sure this is data frame because we defined this as data frame ourselves, right? So this is a very simple example of how you can actually create a data frame inside Python, and then we will quickly look at, now that we have a data frame defined, what all we can do inside Python with this data frame. Right now, again, this is not going to be very detailed today. This is just a glimpse for you of what we will do when we do pandas in much detail, but then just to show you guys as to what all is possible using this, let me quickly show you a couple of quick functions, right? So the first thing that you can do is df.count. When you do this, then it gives you for every column what is the count of values, right? Then there are 5 name values, there are 5 age values, there are 5 gender values, there are 5 ID values. And if you, let's say, specify, let's not get into those complications right now. Let's look at these functions. We will do these later on when we do the detailed uh, example. What is the min one, right? So this is when you do the min, then this is going to give you the minimum value from all of these fields. Now you may be sure ID value 1 is minimum, age value 15 is minimum, but then how is name Amit getting picked as the minimum name, right? How is gender F getting picked as the minimum gender, right? Any clues, any ideas, guys?
I think this was the alphabetical order.
Sorry.
Because of the alphabetical order.
Yes, this is alphabetical order. So what it is doing is every character has a ASCII value, right? And this is actually comparing the ASCII value of the first character for all the names. And simply put, if you want to understand it this way, alphabetical, that is totally fine. This is actually looking at alphabetical order. Minimum would be Amit in this case. Same ways we can also do max.
And
So for every field, this is going to give you the maximum value. So ID 5, age 43, gender is going to be M, right? What else we can do with data frames? Let's quickly look at this. So when you look at df.size, then it is going to give you 20, right? What does it mean? Where is 20 coming into picture? So we have, see, 4 columns, and then we have 5 rows, right? And when we multiply 4 into 5, this is what the size gives me. 4 into 5, 20. So basically this is nothing but columns, the value of columns, the maximum columns into maximum number of rows. This is what the size gives you, right? There is also another function which is shape. Sorry. So when you do shape, then you see what is the total number of rows, what are the total number of columns. So in a sense, shape and size are related. Now, how this is going to be, helpful is, guys, usually, I mean, I gave you this example of creating a data frame by storing a dictionary as data frame, but then this is not how we actually define a data frame. Ideally, if you have a CSV file, right, which is given to you, on which you need to do any exploratory data analysis, or you need to do any kind of a, advanced analytics inside Python, then you'll be amazed that by just writing one line of code, you can import the whole CSV file inside a data frame, and it will appear as if this is getting imported from a CSV file or a XLS file or a JSON file for that matter, right? So this is where the beauty of it is going to be, and we are going to definitely see it all in much detail. This is just a glimpse and or an introduction, right? What else we can do with data frames? So we can invoke this function named info, and what this does, it is going to show us the some information. Right now, let's quickly look at what this information is. So it is definitely going to show me all the column names. So these are my column names. These are my, if you look at non-null count, right? So non-null count, what does it mean, right? You may have missing values in these fields, right? Right now we have all the values available for ID. We do not have any missing name, right? We do not have any missing age. We do not have any missing gender. All of these values are present. But what happens in the real world? In real world, you may not have all of these values and as non-null values, right? You may have hypothetically age missing for this record, right? Or a gender information missing for this record. In that case, uh, this function, info function, is going to show you uh, how many values are actually available as null as well. So this is what it is going to give you. And now this is the data type, right? If you look at it, this is int64, means 64-bit integer. ID is a number, so this is interpreted as int. Age is a number, so this is being interpreted as int. And anything other than int or float or date data type, this is going to get interpreted as object. And this is what our info function does. You can simply say that if it is a string, then it will get a data type of object. Uh, but you may be wondering why object, why not str string? Because we have already seen that Python data type for string is str. But right now, what we are talking about is a data frame data type and not a Python core data type. And everything other than int or float and date is going to get stored as an object here. And we will see if we need to do any manipulation, how to convert this into uh, a string. We will see that later when we require this. In terms of memory usage, right, it says that we are using 288 bytes of memory to store this data frame, this one. So pretty meaningful. It gives you, if it gives you a very quick information on what actually we can uh, do with, or how our data frame is set up right now. So this is something about the data frame. A very interesting thing to do with data frame is describe, right? When you do describe, what happens? So let's quickly look at this. And I'm not going to explain all of this right now. I'll leave it for the later when we do pandas in much more detail, right? So all the numeric columns, right, which are only roll and score here, they are going to get described in much detail, right? And what is going to happen? If you look at the first column, part of it is really simple, guys. Count is the total number of count for roll that we have. Of course, we have 6 values in both of these fields. Now, then we have minimum value. So what is a minimum value for roll and score? When you look at it, this field or this row, what is the maximum value for roll and score. So it is giving you the min and the max. The same way we have the mean, right? So mean is what is the mean value, or what is the average value? What is the average value for a roll? What is the average value of score? Since my numbers are not jumbled up, it is both of these giving me both of these are giving me, wait, I have not executed it. Wait, I have executed it now. Yeah, so these are IDs and ages, right? These are IDs and age. So we have five count for ID and age. Their mean are different, right? ID for mean is 3. Mean for ID is 3. Mean for age is 24.4. Minimum value is 1 and 15, and maximum value is 5 and 43. I'm purposely skipping STD, standard deviation, for now, and these 25%, 50%, and 75%. We will cover these later when we do a little intro to statistics. So with this, guys, do let me know if you have any questions with the data frames. I'm hoping and assuming that you guys are finding it is interesting to get introduced to Pandas data frame.
Yeah, it is. Can you just recap for describe function?
Sorry,
Can you please describe function? Recap for the description.
describe function.
Yeah,
Okay, so describe function is a very simple function. You can invoke it with any data frame, right? So what we have done is our data frame variable name is df. We are calling describe method with df. So df.describe. What it will do
so
is first things
describe
first.
something for the integer code, right? No,
Yeah, that's what I'm saying. That is what I'm saying, right? So for all the you have already seen this here, right? Info, right? For all
yeah,
the data types which are either integer or float, right? So here it is
mhm,
ID and here it is age. Only for these fields it is going to give you some summary statistics. What it is
right,
showing you here is summary statistics, right? And some of the data items of a summary statistics is you would want to quickly know what is the count of values, what is the average or the mean value, what is the minimum value, what is the maximum value, and this is what it quickly shows you. See, there are other ways of doing this as well. You do not necessarily need to do describe, right? But
right,
describe is an easy way of doing it, right? What we can also do is df id.count. We can do that. It is
right.
also giving me 5, right? We can do df age dot max. Let me just put this into a print statement. So we can do this as well, right? So right now we are specifying that give me the count of ID field, give me the
Right.
maximum value from the age field. This is what we are trying to do. But then if you really need to, do it for any specific column, then you can do it this way. What describe does it is it lays all of this detailed information in front of you really quickly without much effort. The syntax is very simple, and you get all the information in a single go. Whatever you need to look at it, you can just look at from here. But then there are other ways of I won't say simple. This is definitely not simple looking in terms of syntax. This is much simpler to write.
Got it. Thanks.
Sure. So with this, let me get to NumPy and try to finish this. This is definitely not going to be difficult at all, uh, because NumPy is, for now, we are going to just look at a very basic introduction. Like I said, and I showed you today as well, NumPy is going to be a detailed discussion altogether. It may require us to do one more full session on NumPy. So we will look at NumPy later on. But then what is NumPy as an introduction, right? So it is a Python library used for working with arrays, right? Now, what are arrays? Is something that we will look at. It also has functions for working in domain of linear algebra, Fourier transform, and matrices, right? This is also something that we will look at it later in much detail. And this is an open source project, and you can use it freely, right? So how do we import NumPy? you import NumPy uh, as a package named NumPy, and like always, we prefer to give aliases. We are going to specify alias here as well, right? So import NumPy as NP, and then we can use np dot array, this function, to define a array, which is going to be a NumPy variable. So let me first try and explain this to you as to what exactly is an array, right? So an array is nothing but we already showed you how a memory looks like, right? So if this is your memory, then this memory is divided or grouped or into different memory locations, right? So let's say I'm not going to draw the whole diagram here. That may not be needed, but then if this is how the memory is divided or segregated, what if you need to store more than one numbers, right? Which are related to each other. Let's say we have a value of age, right? We have multiple values of age which are available to you. So uh, we have 23 available to you, we have 30, we have 45, we have 17, and we have 20. Let's say these are the five values of age that we need to store. Now, ideally, you can store the individual values of these, first value, second value, third value, fourth value, and fifth value. You can store all of these at whatever memory locations. That is totally fine. But when stored as an array, what happens is you will actually specify an index to these, right? And the array name would be a single variable name. So ideally, if you look at it, these are five different numbers, right? How many variables do you need to store five numbers? You will need five variables, right? This
Yes.
will be first variable, this will be my first variable, this will be my second variable, this will be my third variable, this will be my fourth, and this is my fifth variable, right? Now the thing is, there is no harm in storing them as five different variables, but then does it really make sense to store them as five different variables? Because all of these are related, right? In a sense, these are all age numbers, right? These are all age numbers of different people. So they all convey the same meaning. So why store them as different variables? Why not store all of them as a single variable where we can call them via indexes, right? So how this is going to work is, instead of storing them into different memory locations as different variables, you can store them as an array, right? So what will happen in that case is, you will have a single variable, right? In this case, we can define this as an array with name age, and it will have five different memory locations, one for each value, and then it is going to store all of this in different memory locations. And you may be wondering how this is going to be any different, and I'll quickly explain that how this is going to be different and why this is helpful. Is all of will have the same name but different indexes. The index of this is going to be 0, 1, 2,
Three, four.
3, and 4. So indexes in Python start from 0. The benefit of storing all of these values as array is it will have a single variable name, and it will be stored at adjacent memory locations. So retrieval is going to be fast, and you will be only required to deal with just one variable name. You will not be required to deal with five variable names. If you need to store or retrieve this value, right, what will we write? We will write age
Eight
0,
bracket
0, right? And for this, we will write inside bracket,
one.
we will write 1. And likewise, for this, the last one, which is a fifth one, we will use 4. And this is how it is going to be. So I hope this, explanation kind of clarified to you guys that why we need an array. We only need array when we want to store multiple values which are related in some manner in a single variable. At
Right. So collection
at
of same data type, right?
Sorry.
Array is a collection of same data type variables.
Yes, yes. And also here, like I said, related, then if one age is a number, then another age cannot be a string or a date, right? This is kind
Yes.
of implied that this is going to be all of the same data type. So I hope this is making sense to you guys. Let's quickly jump into this example where we define how we see how to define a NumPy array, right? So, uh, like I already told you, we first need to import the library. We have imported the library NumPy as NP. This is going to be the alias, and now when we need to define the array, we need to define the array this way. So what we are trying to do is, this is again a list, right? Guys, all of this is going to be a repetition going forward, and you need to identify where we are using a list and where we are using a dictionary, right? So earlier,
Yeah.
to define a data frame, we were using a dictionary, right? Now to define an array, we are using a list. I'm so sorry. So we are using a array, or a list to define an array, right? So what is going to happen? We are going to actually define an array with the name ARR, and this is going to store these values 1, 2, 3, 4, 5, and then we can actually print these to see what is happening, right? So see, when we print the values of array, this is going to print 1, 2, 3, 4, 5, and when we print the type of this variable ARR, it says class numpy.nd array. So nd array it means n dimensional array, and we will just see what a nd would mean. But then right now what we are looking at is a one dimensional array, right? Because it has just one dimension, it has a row, does not have a column. So the way we have defined this array, this is a 1D array. This is a 1D array, one dimensional array. You can also define an array like this. In that case, this is going to look very similar to a data frame or a table, but you can define an array which may look like this. So you may have a 3 by 3, 3 cross 3 array, right? Which means 3 rows and 3 columns, and you can have different values in there, whatever uh, values you have. This is also an example of a 2D array, right? Now, the dimensions could be anything, right? It could be 3 by 3, it could be 2 by 3, totally depends on what actually you are working with. This is also an example of a 2D array. This is also a 2D array. The dimensions can vary, all the data types will remain the same, and the values can vary as well. So this is an example of a 2D array, right? We will see how to define a 2D array, but then first look at how to actually retrieve the individual values of this array, right? So like I already told you, if we need to retrieve the first value, then we can simply write or retrieve this using the index. Let's see, if we need to retrieve the third value, then we already know that the indexes start from 0. So this value will have a index 0, this one will have a index 1, this one will have a index 2, like I told you, right? The first value will have index 0, 1, 2, 3, and 4. We can specify the indexes as well. So we can specify 2, and we are trying to actually by 2 wanting to retrieve this value 3. So it works fine, right? This is how we define an array, and this is how we print an array. This is how we print the type of array, and then this is how we retrieve the individual values of the array, right? We will see the practical implication of this, but then for now we're just having a glimpse of it, right? The other one is, how do we define a n-dimensional array, right? We already seen that. This is example of a 1D array, right? We just have, this is what? This is 1 cross, this is 1 cross 5. So this is one dimensional array, right? This is a one dimensional array. Now here we have 3 cross 3 and 2 cross 3. And these are examples of 2D arrays, right? How do we define 2D arrays, right? The syntax is going to be not very different, right? Here we were having one list. What we are going to do here is, if you look very closely, we are having two lists, right? This is my first row, this is my second row, and both of these lists we are enclosing inside another list. If you look at it this way, Let me clarify this a bit. I think it will be much clearer now, right? What is happening? This is my first row. This is my second row. So what kind of a shape this array is going to have? Can anyone tell
2
me?
into 5.
2 into 5, exactly. So 2 rows and 5 columns. And then we are enclosing both of these inside another list. And we are calling this array underscore 2D. And when we define this, actually what is happening is we are getting a 2D array, right? And it is getting printed as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Its type is also in numpy.nd array. So in a sense, if you look at the type of a one-dimensional array, it says nd array. And when you look at the type of a two-dimensional array or any dimension array, it will continue to say nd array, because Python does not differentiate between dimensions. It is totally for you to interpret what dimensions you are using. Python is always going to call it as n-dimensional array. And here n could be 1, 2, 3, 4, 5, whatever dimensions you need to work on.